Hello all and welcome to today's seminar hosted by the International Inequalities Institute at the LSE. My name is Valentina Contreras and I'm a research officer at the III. I'm incredibly pleased to be chairing today's seminar titled The Gini and the Tonic, Understanding the Dynamics of Inequality Measurement, which is part of the III Inequalities Seminar Series. Today's speaker is Professor Sanghamitra. Sanghamitra is Professor of Development Economics and the Deputy Director of the Center for Globalisation Research at Queen's Mary University of London, and she's also a visiting professor at the III. As usual, there will be a time for you to post questions following the presentation, and we will take questions from both the person and the audience. So all of you and enjoy it.
Thank you so much, Valentina, and thank you to the organizers of the seminar series, and thank you to all our lovely colleagues who are here, and thank you to colleagues who are online for attending my presentation of a piece of work which has taken me more than 15 years to complete. So the paper has a title which is sort of suggestive of where the paper is going to go. Sounds like there might be some problems with the Gini discussed, and there's a solution provided for the problems that we encounter. And overall, basically what I discuss in the paper is about how do we deal with problems we might encounter if we want to try to measure inequality over time, and if we want to use an inequality measure in some kind of, could be econometric analysis, it could be a sociological analysis over time. So that's the main concern that we have. And I'm going to tell you a tiny story about this paper, where it comes from. It actually was born whilst I was actually doing my PhD here at LSE, which is a very long time ago. So it was actually born in LSE. And many of us who were doing our PhDs at that point of time, we would run lots of billions of regressions at that point of time. We would sort of throw them into a program, and we'd throw in this. That was the era of the panel regression techniques exploding. So we were all the panel regression kids, and we were throwing in inequality measures, anything we thought that meant might explain whatever we're trying to explain. And so inequality measures used to get thrown in quite a bit into panel regressions. And we found, not just me, I mean, the studies that came around at that point of time found that we understand, it's very, very clear, inequality matters, whether it's income inequality or wealth inequality, it could be social inequality, it does matter. And we have these high quality data sets. It's screaming that it does matter, but it would never show up to be significant in our estimations. And that was sort of ringing bells for all of us, including myself. So that's where it started. And the paper's really simple. The paper's no longer a paper anymore. It's now turned into a book. But at that point of time, the paper was meant to be about what is it about these inequality measures that we're using over time? What is the problem with them, if there is any? Is there a problem? So that was my question. And the answer is very simple as well. I've got some very simple explanations for why we have these problems. What were the problems? Why we had those problems? And we still have those problems today if we were to use measures like the Gini, or which look like the Gini. And the answer is very simple as well. I provide a bit like, an engineer, a toolkit of tests by which we can actually test what are should I be using this inequality measure? If I can't use the Gini, which one do I use? Should I use any at all? So this question's simple. The answer is also very simple, but I did not have a simple journey. There was about 15 years in between of, I don't know how many research assistants I've had support me on this project. It went on and on and on and on, because I kept testing. So basically what happened was I was looking at, in my research, at the dynamics of inequality over time. And like myself, there was a profusion of studies at that point of time which were looking at dynamics of inequality over time. And it turned out to be, at that point of time when I started my research, when I was a doctoral student and a postdoctoral student, all we had if we looked at time series inequality measures, all we had were Ginis. So the scene has changed in the last 10 years or so, but for a very long time, all we had were time series of Ginis. And this was actually a concern that already was under discussion within the inequality measurement literature, that we shouldn't be, there's a lot of other inequality measures at our behest. We shouldn't just be using the Gini. Now, empiricists like ourselves, or empiricists who work, for example, in country offices or at the World Bank or in the national statistics offices, we're trying to understand what are the determinants of inequality in any country of the world. They just have access to the Gini. That's how data sets were constructed at that point of time. And so basically, for a large number of studies all over the world, people conducting empirical research, national level or sub-national level, we still also have just Ginis and not many other time series statistics on other measures of inequality. So the problem is not really fully resolved. So we still have to deal with cases where we might just have to work with the Ginis that we have at hand. So in what I do, this is the main findings of the paper I'll be presenting today, but this is now sort of turned into a massive, not a massive book, but into a book, which is coming out later on this year, that I found that specifically, we find that if you want to undertake any kind of dynamic analysis using inequality measures, you have to be very careful about using them, because for somebody who's like a time series econometrician and you were to use their little toolbox to test, can I use this particular measure, whatever measure it might be, if it's the Gini or if it's any other inequality measure, it seems like these measures are most of the time not satisfactory. They don't really pass the tests to be used as a satisfactory measure. And what I also particularly highlight in one part of what is now the book and was originally this paper is that if we are to use it for panel regression purposes, which lots of us in organizations like the Inequalities Institute or any research department of the World Bank or National Statistics Office, we often run panel regressions. We've got some very, very serious problems to encounter. So we've got an amber warning and we've got a red warning from the research that comes through. So basically, yes, so just to go over this one more time. So why was this a problem? Well, basically, for a really long time, all the inequality data were collected or estimated as Ginis that were provided at the international level. And we also know country level statistics, when calculated at the subnational level, as it's done for many South American countries, a little less in Asian countries, also produce large amounts of Ginis. And a little less of everything else or any other kind of inequality measure which might be relevant for us. So basically for a long time, and even today, researchers still just have the Gini. The problem was that, which I will show to you in a couple of minutes, is that the Gini is a measure which is measured relative to an average of the income distribution. And that's where the problem is. So it's a very simple problem, which can be resolved very easily. But then again, it doesn't mean that we throw out the Gini either. So I'll come to that. So that's why I'm providing a toolkit at the end of the paper, at the end of the book. I provide a whole bunch of toolkits which we can use. It's like walking in like a plumber or an electrician, rather than suggesting that we have a major overhaul in our understanding of inequality measurement. So basically, what's the problem of having measures of inequality where they are measured relative to the average? The problem is that there's a huge literature in macroeconomics or macroeconometrics where they find that if you have a measure which is a metric which is measured relative to an average, they find that the dynamics of the average, so the mean which is used in the relative inequality measure, has a huge amount of sort of control over the performance of the entire metric. So the underlying GDP dynamics, if it's calculated at the national level, or income dynamics, which get compounded into the average of your inequality measure at the bottom, and the denominator has huge amount of power in determining what will be the dynamics of the inequality measure itself. So basically, this gets passed on to the relative inequality measure. So your inequality measure now, unfortunately, is carrying a lot of unwanted information and dynamics of whatever was there at the bottom of your relative inequality measure, of the, at the denominator of the inequality measure. It's really as simple as that. So how are we going to progress in this paper? So what I first do is I put together for the first time a 100-year data set of 12 different kinds of inequality measures. Well, I've got a data set of 18, but I'll show you results with 12. And for 34 countries, and for at least 100 years. And initially I started to see if I could do it with income. It wasn't, I didn't get a good spread of countries. So basically I used mortality distributions, and I'll talk to you about that, putting together the data set. And so basically I got mortality distributions for 34 countries for over 100 years, and then I estimated those 18 inequality measures from these distributions to get 18 inequality measures for 34 countries for over 100 years. And then what I do is I basically turn myself into a bit like a sort of a time series person, and I go through the whole range of time series tests to see, okay, do they perform well? Are they satisfactory from the time series empirical point of view? And so for that, I do a whole battery of tests, and that's sort of the boring part of the paper, but I'll take you through what the answers that come through. And then basically what I do find is that if we were to use absolute inequality measures, we find that there are more cases where they actually are very, very satisfactory to be used for time-dependent studies. So whether you want to use them just for plotting trends or using in a panel regression analysis, whatever kind of time-dependent study you take as your research base, you can comfortably use an absolute inequality measure. But we also find that sometimes the Gini or other relative inequality measures actually may not be problematic. And that's because it could be that the country we're looking at does not have any problems with its income data. So the problems meaning time series problems. It could be that it has very particular characteristics which influence the GDP data or the income data, and that gets passed on to the inequality measure. But that's not probably what we were interested in. So I'll take you through that in due course. And then what I do is an application. Let's have a look now that I've constructed all these inequality measures I've got this panel data set of these 18 inequality measures. Let's apply it to an application and let's see what it looks like. And we find that we actually get much more stable results when we're using absolute inequality measures than if we're using relative inequality measures. And that sort of resonated with our experience as empirical researchers. And I was working with developing country data. There was just absolutely no confirmation between the results of using relative inequality measures and the absolute inequality measures. And that result was sort of coming through with this research as well. So it was very clear that if we were to have absolute inequality measures to use for empirical analyses, if there is an effect of inequality, then we would be able to. That would come through. That would have an opportunity to come through, but otherwise it would get lost. So, and after that, I do perform a few more empirical analyses. Again, I'm doing some tests which are very popular within the macroeconometrics literature. Let me just see if that's on the next slide. Yes. So after that, I use a vector autoregression analysis to see the effect of a shock. So for these same countries, I look at the effect of a shock on, again, inequality and growth, and to see if the effect of the shock is retained or if it dissipates over time. And we find that for relative inequality measures, the effect of the shock is actually retained for much, much longer than it is for absolute inequality. So if it turns out to be that as an effect of, say, a recession, inequality in a country goes up, then if you're using a relative inequality measure, it takes much longer for the relative inequality measure to get rid of the effect of the shock than it does for absolute inequality measures. So it could be that the effect of the shock has actually long gone in the society we're looking at, but the relative inequality measure will incorrectly continue to show that the effect is still continuing. Therefore, we should have actually been using an absolute inequality measure, which will actually show the effect of the recession actually having left the economy. So that's what we, again, that's also very clunky, big estimations. I'll take you through that as well. So we find, or to tell you specifically what we find, that we find for absolute measures, it comes back to the normal much quicker, about 10 years earlier than for relative measures. So in other words, most of the relative measures would carry with them the effect of a shock longer than our absolute measures. And right at the end, again, I've got another set of toolkits for people who are in a rush. So you've got, or for example, you're in a developing country and you don't have, these massive computing technology with you, and you don't have, Stata 18 or 19 or Stata, R, and you just can't sit there and you do these massive calculations. These estimations are a bit technology intensive, but there are tests which will give you more or less the same result. And I've identified those tests. And so somebody who's in a rush and you want to do some quick tests on some inequality measures, should I use them or not for this particular country, for this particular time period, then I've provided those as well. And basically, these characteristics are also exhibited by, if you were to look at the clustering of volatility of your inequality measures over a time period, and also looking at the normality of the distribution of your inequality measures over time. And basically, it all begins to sort of fall into place if the distribution is non-normal, and if there's a huge amount of clustering of volatility in the inequality measures estimated. These are the ones which basically are carrying a lot of information which doesn't belong to its own distribution. And therefore, that's what's distorting their performance. So that's so these are the quick tests you can do to reveal the same results that I'm doing using the bigger tests over there. Okay, so just to take you through, so what was the problem? So as I said, the problem actually turns out to be, it's a really, really simple problem. So I've used the example of a Gini. This is our favorite definition of the Gini. And as we know, our Gini basically can be expressed either in its original form, as we saw in the previous slide, or we can just say, it's the absolute Gini relative to the mean. And it turns out to be that it's the problem lies in this mean, the mean of you. So you've got your distribution and you calculate the mean and you calculate the inequality measure. And it's basically the dynamics of this mean is the problem. So if you and I were to actually just work with the absolute Gini, we'd actually be fine. So that is one solution. We could be working with the absolute Gini. That's one of the things that comes through. So what I'm going to do next is show you how I've put together my data set. I'll keep that quite quick and give you some plots to see how different the results can be, depending upon which inequality measure you use. So what I did was there's a database called I'll just go to the next slide just to tell you where the database is. It's called the Human Mortality Database. It's a fabulous database, which collects national statistics of death rates and life tables for national populations. And it also gives you death counts with vital stats and birth counts. So what we use is death by age, available from 0 to 100 plus, for total male and females and the total numbers. And we've used the distribution of total mortality, that's the variable that I used, which is basically the total number of deaths at age X as our base distribution. So I had a distribution of total number of deaths at age 0, total number of deaths at age 1, total number of deaths at age 2, goes on all the way to 100, and then you have the distribution, right? And then you use that to calculate your inequality measure. So I have this massive distributions, a data set of distributions of age at death, and therefore the inequality measures for each country, for each year, and for 18 inequality measures. Okay, and I was going to go back to the previous slide, wasn't I? Yes. So I used that to calculate, basically this is more or less the battery of inequality measures we typically use. As you know, it's a massive literature. We could estimate more. So on top are the family of relative measures, and we've got the new popular ones, the percentile ratios, which basically are the way forward. And then we've got the percentile shares, the top 1%, 0.5%, 0.1%, right? We did as many as we could. And just to tell you a little bit more for the application, which happens a little bit later, I had to collect data for these variables, which are standard variables for an inequality and growth analysis. These variables were our control variables. Of course, I didn't have the full data set, so I had to do some projections. And the details of the projections in the paper, if you're interested, I can show you how we calculated those projections. This is more or less a set of countries we have. We have more countries than this, but just to give you an idea what the countries we have. And we basically end up using 34 for our analysis. For the projections, this was a basic model we used, and we did lots and lots of models just to see which one gave us the most stable fit. And it turned out to be something like this, works out to be a nice stable fit, which allows us to fill in the gaps and do some projections. So that's our talking about the data. So now we can see what it looked like when we plotted the data for the Gini. So these are the trends for Ginis, and it starts in 1900, ends at 2012. Should be 2012. Maybe it's 2005 over here. And as you can see, this is the
class.
Yes.
So why is it that you use UK and US as the lagged variables?
Oh, that's for when we had missing gaps for the control variables, which I'm going to be using later on for the panel regression analysis. I actually didn't need it for the mortality. So for mortality, we had the full data. So for when we do the panel regression analysis later on, I will be needing some control variables for investment. Education was one of the variables for which I had incomplete data. So then we had to do some projections to fill in the missing gaps or to extend. And this was the model that was used. And we've used many, many models. I mean, for example, you can see we've worked with Denmark, Switzerland, Sweden, so to replace these particular country values. Yes.
Very best explained.
Yes, yes. It wasn't needed for inequality because for that we had the full distributions. So this is mortality distribution, right? So therefore, it's not surprising for us that during the two world wars, and this is probably Spanish flu as well, that there was very, very low levels of mortality inequality because there was indiscriminate mortality for all age groups. So that's the reason why it's quite a fascinating part of the graph. So we can see what it looks like, for a whole bunch of countries here when you use the Gini. And let's have a look at what happens when we use a different inequality measure. So this is for the tile. I've just used 5 because it's just a bit easier for us to look at the graphs rather than having 7 countries. We can see you can see how different they look. You can see more or less that they're sort of trending in the same way. But you can see that the levels are quite different and the dynamics are quite different. And have a look at what happens when we use mean log deviation. So we have a lot more variation that's available to us to look at. And we can also see that, especially around the areas where we have the Spanish flu and the mortality from the 2 world wars, it begins to look very, very different, right? So we can see, if you just plot them as they are, sure, over a period of, 100 years, yes, they're more or less moving in the same direction. But if you want to home in on a certain specific set of years, you can see that the results are quite different. How about we have the same country, but 2 different measures? So this one I have for a whole bunch of countries. I don't know if you can read the names of the countries from the distance. So the first country on the top left is Australia. The next one is Austria, Belarus, Bulgaria, Canada, Czech Republic. Then we've got Denmark, Finland, France, Hungary, Iceland, Ireland, Italy, Japan, Latvia, Lithuania, Luxembourg, Netherlands, New Zealand, Norway, Poland, Portugal, Russia, Slovakia, Spain, Switzerland, Taiwan, UK, Ukraine, and the US. And you can see for the same country, for the time period, again, it's exactly the same time period, 1900 to 2005, we can see that the inequality measures, if you use, or what's happening to inequality is very, very different depending upon which measure of inequality you're using. So, for example, for Australia and Austria, they're going in completely opposite directions. So Hungary, for example, over here, Netherlands in the second part, Ukraine, again, they're moving in opposite directions. Russia is the same, though this is for a much shorter period of time. It's not for the full-time period. So you can see we get very different pictures. And what if we were to use two relative measures? So in the previous slide, we were looking at the Gini contrasted with a percentile ratio. So the 10 and 50 percentile ratio, which is a very popular measure right now to use. So one of them is a relative measure. Gini is a relative measure of inequality, and then we're contrasting it with a percentile ratio. You can see very different results. But what if we were to use two relative measures? So we've got the Gini, and we've got a generalized entropy measure where alpha equals 2, which is a relative measure as well. And here again, we can see you get very, very different pictures of inequality. So for a person who's sitting in a national statistics office or in a, say, a development office in a developing country, which one do they go with? Do they, if they were to have the computing power to be able to estimate, you know, a G2 measure or a very sophisticated relative inequality measure, which has all the interesting properties that they're interested in, which one do they go by? And how, or if you need to report to the Ministry of Finance about, you know, what's going on in inequality in the country, which one do we go by? So depends upon, it's not just a distinction between relative measures and absolute measures or intermediate measures. It's more about which measure to use. Even within those groups, which one do I choose? Okay, so I've already taken you through this. And so what I do now is I will take you through what is now our sort of little toolbox, which is very popular amongst time series econometricians. And they sort of, it's almost like, you know, basic arithmetic for them. So, and I sort of take you through a couple of the results that come through that, through these tests. And I'm aware some of you here are, you know, not econometricians, which is absolutely fine. I can just give you a very simple overview of what these tests are. So one of them, the first one, is basically saying, is a measure highly trended? So it could be that, you know, the Gini or the generalized entropy when alpha equals 0 or 1 or 2 or the Atkinson index or whichever index you're using, is it prone to carrying too much information if there is a very particular kind of dynamics happening in the country's GDP or the country's national income? Is it possible that it gets passed on too much to the inequality measure? Does the nature of the inequality measure or the construction of the inequality measure mean that a huge amount of relatively uninteresting information for us as empiricists gets passed on from the income dynamics to the dynamics of the inequality measure? So what time series guys like to do is they like to measure the extent of trendedness of these measures. And it's just a fancy name for it. So if you're a stationary measure, if you're a stationary process, it basically means that if there's sort of a hit or if there's a shock to your system, then the effect of that shock will pass off over a period of time. Whereas for a non-stationary process, is a highly trended process where it will actually retain the effect of that shock, and it will most likely not have it sort of pass off. This is just a little bit of the maths describing, you know, how they do the testing. And basically what they do, they're looking into a parameter called D. So they use different kinds of methods to estimate a parameter D. And basically, if after your estimations, if D lies between minus 0.5 and plus 0.5, that's good news. That means it's actually kind of measure which doesn't get very heavily affected by, you know, these shocks. But if it's between 0.5 and 1, it does get affected, but eventually it will come back to its normal process. But so that's called mean reverting. But if it's less than, when it's greater than 1, or when it's 1, the process is not mean reverting, it's non-stationary, as in it's not good news, as in we shouldn't be using it. So there are sort of two sets of tests that we use. So using these, so once by the authors GPH and once by the author Robinson. And what I did was, so I tested for all these measures. So we've got the Gini, the different Atkinson measures, the G measures, and we've got our percentile ratios here and our top percentiles here. And what we find is that for relative measures, we find that we have more cases, more instances of countries which have, which are indicating a lot of non-stationarity. So what I'm trying to say in this particular paper, in this study, is that just because you're a Gini, just because you're a relative measure, it's always bad news. It could be that for one particular country, for a certain period of time, you might run this test and find, oh, it's stationary. But it might be that for the rest of the 33 countries in my data set, they're either non-stationary or eventually mean reverting. But it could be that there could be the isolated few cases here and there, which we do find. For example, the Gini, we find there is one instance where it was stationary. Whichever country it might have been, it was stationary. So we could have used the Gini for that particular country for that period of time as a regressor for our empirical purposes. But we can see that there are many, many more countries, 17 countries, 15 countries, 20 countries, which are non-stationary for relative measures. Whereas if we look at these percentile ratios over here, we can see much more countries. For example, here we go, for top 1%, top 0.1%, we can see that there are many more countries which are stationary or mean reverting. So these, the absolute measures, the percentile measure ratios are also satisfying. This is the basic starting point for time series people, where they want to check, does it satisfy this principle before you can, this test, before you can use it for empirical work. So to summarize, we find that we've got more absolute measures of inequality which satisfy the requirement that you don't want the measure to carry any trendedness that might be present in your income distribution, in your income data. And so we've got more cases of stationary and mean reverting inequality measures, but we've got fewer cases for relative measures. So for the first set of tests, it seems to suggest, okay, we should be stopping and thinking about, okay, how if we want to continue using relative measures, what would be the criteria under which we can do that? So before we move on to further tests, I have an application just to see, okay, what does it look like to show researchers what we could do for further studies. So I have a very standard empirical investigation. At that point of time, when I wrote this paper, this was a hot topic. What is the relationship between inequality and economic growth? And there were lots of panel regression studies that were done. And this is basically a very standard equation, which was estimated at that point of time. Economic growth being regressed on inequality and a whole bunch of country level controls. And I used 4 standard panel regression methods just to see, depending upon what kind of estimation method I used, do I get different results? And before we did that, did the standard stuff of, stationarizing the variables before you throw them into the regression. So done everything that you and I would do as empirical researchers. Now, I believe for you, this might be very difficult to see, but I can tell you that, so this is the set of results for relative inequality measures. So we run those regressions using relative inequality measures, and we can see that the inequality measure is not always negative, not always positive, sometimes negative, sometimes positive. It's not very stable, sometimes not significant at all. Whereas if I were to now repeat the same analysis, I'm going to move on to the next slide. Just have a look at, what's going on with our percentile ratios or the absolute measures. And we can see that, it's actually quite interesting. With the majority of them, and this is the last measure, the Colm measure is an intermediate measure of inequality. They're either not significant at all, and there's only a couple where they're significant and they're negative. But we can see that we get a much more stable set of results when we're using absolute measures. So that was the result summarized the application, which confirms our earlier understanding or our initial understandings of the problems where the problems with relative inequality measures come from. So what I thought, we could do is, why don't I generate absolutized versions of these relative inequality measures? So in the first slide, which I showed you, we had the relative inequality measures as they are estimated. And then I thought, okay, what if I were to convert these relative measures into their absolute versions, so just multiply them by their means, and to see if the problems resolve? And lo and behold, we get very similar results to the ones in the previous slide where we use just absolute measures. And we can see that, here we go, there's no effect of inequality on economic growth. So, and we can see it's really stable. It's not significant at all for any of the regressions. So it's kind of again, we're seeing the same results over here, that at least for the data set that we're using, the effect of absolute inequality on economic growth is nice and stable. There is no effect at all. Whereas if we're using relative inequality measures, we get positive, negative, significant, not significant. So it's a very unstable set of measures. So that's the summary of the results over here. So what I can do is now sort of provide you with just two more sets of tools that we could use. I did another set of tests for the dynamics, just to see, again, there's a very popular field in macroeconometrics where they have a big VAR models where they can see the effect of a shock of on this relationship between inequality and growth. And I sort of, following that literature, did similar estimations. And they generate something called impulse response functions, which basically are these, which tell you so each box tells you the story of what's happening between inequality and growth, if there's a shock to that system, so for each different inequality measure. And it's probably not so clear over here, but in general, the result for a 10-year horizon, over a period of 10 years, we can see the effect of a shock. If it's a relative inequality measure, it doesn't really dissipate. You can see that there's not much of a change. It looks more or less the same. The confidence intervals are not narrowing, so there's not much of a change. Whereas it's a little bit better. You can see that this is for mean log deviation. You can see that the impulse response function is a bit more flat, as in it indicates that the effect of the shock that we've measured over here is dissipating over time. We've got the same thing for a 20-year horizon, where we can see for mean log deviation over here, you can see it's completely gone, whereas for the relative measures on top, you can see there's still quite a bit of dynamics. There's a lot of wiggling up and down. So again, we're using different methods to see the relative measures are holding on to the effect of the shock, whereas if you were to use an absolute measure, it actually, if there was a shock, that's fine, but it dissipates over time and it goes away. It dissipates much quicker for an absolute measure than it does for a relative measure. So in other words, it's holding on to information which is not informative for us.
This might be a silly question.
No, not at all.
But how do we know that this information is not relevant for us?
Yes, that's a very good question. We know that because the retained information is an information which has been introduced because of the nature of the measure. So if we were to deal with just inequality as we measure it using differences or any of the absolute approaches to understanding inequality.
I get that, but it's more of, I don't know, like...
Yes, I know what you mean. And did we need to get rid of the information? And that information is not information about differences, right? So the extra information that we have because of having a relative inequality measure is the information about just the income dynamics. It's not about the distances between the individual members of the income distribution, right? So it's it's information about the stochastic process of the income, right? So you're carrying information about the stochastic process which has nothing to do it's about the GDP trend in itself. It's more about, the macro information, the macro time series information of the GDP process or the income process. It's not about the distances between the different individuals in the income distribution.
So we were using absolute Gini instead of
yes.
About just using top.
Yes, absolutely. Or it could very well be that you can continue to use a relative measure. And it might, if you do the test and the test indicates it's not trended and it's not carrying the information, then there's no problem with it. Just carry on using it the way it is. You can use it neat. And this is where I would have the long, lengthy discussions with the editors of the journals. They recommended that, this is all great. Let's have a unified theory of inequality measurement over time. And my response to them was, it's actually not needed. We don't really need to completely reinvent how we understand, how we measure inequality over time. We've got a very large body of literature on how to measure inequality for different situations, and that is extremely useful. So there's no need for us to throw that all out and say, oh, there's a whole group of inequality measures which we shouldn't use at all. And that's not what I'm suggesting here at all. I'm suggesting if you want to use it, but check for these properties which it shouldn't have. And if it has it, then there are many ways of dealing with it. You can just absolutize it and just use that if needed. So that sort of brings me pretty close to the last section. So that's a summary. So that if you were to ask me, were there any specific measures that are sort of coming through in all of the tests that I've done as good performers or reliable performers, a lot of the percentile ratios perform really well. But then again, over the 20-year horizon, we do find that many of the other relative measures actually do sort of come back to their normal performances. So here again is evidence that we don't need to throw out everything altogether. We can carry on working with what we have as long as we have that toolkit with us to do, as long as we've tested for their properties over time. And then again, there are some which don't converge at all over time. And one of them is the Gini. So it could be that there are other, even if you want to stay within the relative inequality measures set, there are others which actually perform better than the Gini. The Gini is very intuitively nice. It's very easy to understand, which is understandably the reason why it's become so popular. But unfortunately, if you're looking at long-term dynamics, it's not the best performer. That was the summary of what we got with the impulse response functions. If I were to now pull them all together, all of the results we've got so far in the last whole bunch of tests, we've got the P90-20, so the percentile ratio is 90 to 20. That has performed really well. The mean log deviation, and also Atkinson measure taking the value 2. It's also sometimes a bit slower in converging. If you remember, we also find that these three measures for the previous set of tests also have very satisfactory performances. So if we were to now say, okay, I really do want to hand over a toolkit to all our empiricists all over the world who have no computing power, for example, in a developing country, and how do they figure out, how can they quickly test for a set of any inequality measure that they might have? It just turns out to be, and I'm not going to take you through this for too long because we don't need to. I have a whole set of results which are in the paper, which basically shows that if you were to look into temporal clustering of volatilities, if you have a distribution, if you have an inequality measure and you want to look at its volatility over time, and you want to see the clustering of the volatility within the macroeconometric literature, it's shown to be a very good predictor of its performance in terms of its trendedness. So that is used, and that's very easy for us to measure. And this result conforms with our findings from all our previous big tests that we've done. And likewise, if we were to do something, if we were to look at the normality of the distributions over time of these inequality measures, that also, non-normality also indicates that it's not a highly suitable inequality measure for our temporal purposes. So these two would be the quick tests that we could undertake. So if you're in a rush and you don't want to do all these big analyses just to check, what do your income inequality, what do your inequality measures, how do they perform over time? Then these two characteristics will give you a quick insight into whether they will perform well over the long run. So to summarize, we've got the, this is just summarizing which, yes, let's get here. So basically what we've found is that over time, there's no need for us to completely throw out relative inequality measures. In fact, what we should do, we should keep them in our tool, in our sort of package of inequalities measures that we need to use. Having said all of that, absolute measures do perform better. So if you have, if you were to be able to choose between, if you've got a set of inequality measures provided to you of inequality data over time, the chances of you getting a more stable set of results are higher if you were to use an absolute measure. But even before you were to throw out anything, you would need to test. Even if it's an absolute measure, you would need to test whether it has all the satisfactory properties. We found that they actually give you more stable results, especially in a panel regression setting. We also found that if we were to use a vector autoregression analysis setting, we can find similar results, that absolute measures converge quicker rather compared with relative measures. But that, again, is not a reason why we should be throwing out relative measures. It could be that for a particular time period you're looking at, there were no major shocks to the system, so they perform pretty well. We could use relative measures. And finally, if you want to do some very quick tests on your measures before you start to use them, you could just do some very quick testing for clustering volatility over time, or checking for non-normality of those measures over time, which will give you a very quick insight into whether the measure has problems or not. The final concluding point is that use inequality measures over time with caution. Have your little toolkit at hand. Thank you very much.
Thank you. Well, thank you very much for your presentation. I'm going to open the floor to questions, and online attendees can use the raise hand function to pose your questions or paste your questions into the chat, stating your name and affiliation where possible. So let's start with questions from the room. Yes. Do you want to take 2 questions?
Yeah, sure.
Okay. Let's go for you to.
No, after you.
Right. So thank you very much for doing the hard work and figuring all of this out. It's too much for me. Where your attention really towards the end was focusing on the validity of these different measures, or rather the utility of these different measures in longitudinal analyses. But of course, where you started was also comparative, where you might want to be comparing, Italy to France to Sweden to whatever, wherever else. So how does that come back into frame here in terms of guidance that you would have for the use of these measures when you're not only doing something which is maybe a time series analysis, but where you're also interested in comparing across the different data points that you have?
Across different, so you mean
so let's say
analysis?
Yeah, right. Where you're looking at your mortality data, your income data across 50 countries, and your interest is not just on the generic time trends across all 50 countries, but in comparing different trends within the 50 countries.
All of this applies to always across the 4 trends. So it doesn't apply. So I have provided you with a framework by which you can compare, do I use the Gini or do I use an Atkinson index of inequality for the same country or different countries over time? But if you were to look at, say, for example, inequality in the UK, this particular year, 2024, and you were to look at the Gini and you were to use the Atkinson index, I have not provided you with any information how to distinguish between them two. So it's only for dynamic analyses.
But what if your interest is on like the differential strength of the effect of inequality, say, between Uganda and Sweden in your time series analysis? With the directions that you've given here hold for that as well?
Yes.
Yeah? Okay. Thanks.
Yes, absolutely. So if you were to want to compare inequality, how inequality has changed over time across Uganda and Sweden, did you say? Then absolutely. And what you could do is you could quite literally estimate at least 2 to 3 inequality measures for Uganda and Sweden and plot them. And if you feel like there's a huge amount of difference between the plots, for example, if I were to take you back to all the way to the front, you will see that depending upon which measure you use, you can get very, very different pictures. So the difference between this one and this one is quite significant.
Right, exactly this. So then
significant, it will raise alarm bells for you.
Exactly.
And you would wonder, so which inequality trend do I trust? And which one do I recommend, for example, to their national government says, look, this is the state of inequality in your country. And in that case, so what you would do is you would then see, so this is for mean log deviation and the previous one's for the tile. And you would then perform these tests on the mean log deviation and the tile and see for Uganda and for Sweden, how are they performing? If the tests say, no, it's fine for both of them, it could very well be that there's no problem. No problem from a time series statistician's point of view, that no, these measures are actually fine for Sweden and Uganda, then your conclusion would be that this is the picture for Uganda and Sweden, if I were to use a mean log deviation, and this is the picture for if I were to use a tile, and they do not suffer from any statistical problems in how they are portrayed in these graphs. So they don't suffer. So you could use either of these and you could trust both of these because the tile provides one set of information and the mean log deviation provides, in terms of how you measure inequality in the country, they provide 2 different kinds of information. So, but both can be trusted.
I think I'm with you in all of that. The tests that you've done right now are basically, continuing with the example, specific to particular countries, right? So I'm wondering if the focus of your analysis is inherently comparative, if there would be any further tests that you would envision to ensure that the comparison is valid, not just that each individual measure is valid, the applicability of each inequality measure is valid, but the comparison across countries, say, is valid.
I think the better way to understand or for me to present your question is, what we're trying to do is I've got this machine in front of me. So I have this, I have my phone. Let's suppose this is a car and this is a army tank. Got two machines in front of you. And you want to test how they perform. Now, this might be a British car, this might be a French car, this might be a Swedish car, this might be a British tank, this might be an American tank, it might be a French tank. We don't care whose tank it is or whose car it is. All we're trying to do with these tests is seeing, is this car satisfactory or not? So if it could be a British car, it could be a German car, it could be, but this is a different entity altogether. So the car is different from the tank. They're not the same. So they will have inherent differences in them. But I don't mind whether I use a car or I use a tank, because you have a reason why you chose a car and why you chose a tank. So I'm not questioning which one you use. Or what I'm questioning here is, if you're going to use the car, just make sure that it's a good car. And if you're using a tank, just make sure it's a good tank. And it's entirely up to the researcher whether they want to use a Gini or a tile. There's no problem, whichever one they use. And likewise, you were saying, is it comparative across countries? It could be. The distinction could be, but it's not so much about the difference between countries, because it could be a British car, it could be a Swedish car, it doesn't matter. All that matters is, if I'm using a car for Sweden, if I'm using a tank for France, are they performing the way we want them to statistically perform? That's all we're checking for. Are they robust? Are these healthy? Are they, do they withstand the test of all these statistical properties that we want them to satisfy? So it could be comparison across countries of the same variable, which is what we're doing here. So it could be that the French car is fine, but it could be that the Australian car is not fine. So if you were to do all the time series tests that we did for Australia, for the Gini, this is tile, so Australian tile might not satisfy the time series test, but it could be the French tile is actually satisfying the tests. Yes, so it could be comparison across countries for the same measure, or it could be comparison for different countries, different measures across the same country or across different countries. Yes, so all that matters is whichever it might be. It could be a British, it could be the UK tile, it could be the Ugandan Atkinson measure, it doesn't matter. As long as that is your entity, whatever the entity is, just run it through the tests and see if it's being satisfied. Yes?
Yeah.
Thanks. Following up on many things you just said, I would buy everything you presented if I think of inequality as a concept out there, and then I have different measures that try to approximate it, and I'm looking for the best possible measure to do this. But we know that all the measures you've tried effectively are different definitions of an inequality, right? And so I measure different things, and I can also define what I measure. And sometimes I might be interested in relative inequality so defined, sometimes I might be interested in absolute inequality, sometimes I might be interested in the bottom or the top of the distribution. So why should I be worried about some D parameter that the econometricians worry about if I know very clearly which definition of inequality I'm interested in? If I want to measure relative inequality, I won't care at all about this D parameter tells me about an absolute measure, right? Or I might still be interested in using both at the same time.
Yeah.
And comparing these things, and I completely buy that it's a pity that so many people only use the Gini and don't look to all these other measures and what they can offer. But I'm not entirely sure if I understand why you would then say we should discourage the use of these, and because we will measure other things, right? If a relative measure captures things differently, that's the effect on relative inequality, but I can't just say, oh, then let's do absolute inequality instead because the D parameter is different. It's a different inequality that I'm measuring, right? So I'm not sure I follow your normative guidance here for researchers to go with the D parameter, because effectively we will measure a different form of inequality by doing that.
Yes, I'm completely with you. I completely understand your question. So basically the D parameter is just one of the many tests that we can use. So it's not so much about the D parameter itself. It's not like calculate the Ds and, oh, my D is not satisfactory, so I'm not going to use it. It was just one of the many tests that we can do. What the tests have done is to identify that it's not always that every single relative inequality measure will have a bad D parameter, or it shows that there's a huge effect if you were to do the impulse response functions estimations. There's a huge effect of a shock on a variable. It wasn't so much about that. It's more about, you're a researcher. You've made up your mind. Look, for me, the Atkinson parameter, the Atkinson measure is the best measure to use. And suppose you're doing it like your colleague, or doing a comparative analysis across countries or regions. And what the project here is trying to highlight is, if you're going to be looking at it, especially over a long period of time, the variations over short periods of time, so if you're looking at a 5 to 7 year period difference, it's actually not such a big problem. So if you were to look at a long period of time, your relative inequality measures, or whichever inequality measure has the problem, it could be an absolute measure, as we've seen, might have the same problems. Whichever measure you're using, it will basically not be satisfactory from it won't be, I'm trying to put this in a non-technical way as easily as possible. It's not satisfactory from a statistical point of view for use if you are looking at long trends over time. Or, for example, you want to throw it into a panel regression, for example, or you want to throw it into a VAR analysis, whatever, you're analyzing something. And in the process of analyzing, your entry point are the quality of your variables that you're using, the quality of the data of the variables that you're using. And your variable to start with is, I wouldn't call it defective, but it's carrying too much information, which is not directly related to the inequality that you're trying to measure. So it's just like it's trying to, in many ways, a simple way to say, to describe the problem is that your variable is not clean. It's got too much extra information in it because it's carrying all that information, because of being a relative measure, for example. It could very well be. So the
general argument against relative measures, right? Even at
it could very well be, yes. But we saw in the test that even the relative measures always do not underperform. Majority of the time, they are giving us unsatisfactory results. So it's easy for me to, one conclusion, when I was first doing this research, I thought, oh, okay, it seems like it's the end of this day, end of the story for relative measures. And then I thought, no, we can't throw out relative measures. They're extremely useful. And especially for short periods of time. This actually matters if you're looking at long run inequality, at least 10 to 20 years. And that's the reason why I needed this data set where I had to have at least 100 years data to be able to establish the properties that I've identified over here. So the lesson that's coming from here is that there's absolutely nothing wrong for us to continue using any inequality measure that we want to use. So we should carry on with doing that. All that's being added to our current literature or our sort of, toolbox is that we have learned from these tests that if you are to gauge inequality over time, especially for sort of medium run to long run, you should use these inequality measures with caution, because over time, the inequality measures will portray different levels of inequality. They will diverge. They will not be telling you the same story of inequality. But it doesn't matter so much if you're looking at 5 to 10 years. So 5 to 10 years is almost like a static analysis from these tests' point of view.
That's the part where I didn't really quite understand the argument, because even if I just take a snapshot, different measures will tell me different things by definition.
Absolutely, yes.
I'd be worried if they do that across time, if I know that they'll do that at any point in time as well.
Sure. So that's one part, that's one side of, that's one part of the big story that we try to talk about, or we try to tell as those of us who study inequality over time. So as a snapshot or in a short time period, there is not a huge difference that you will see between these measures over time. But if you were to be doing long run analyses, so as we have been doing in the last, say, 10 to 15 years in inequality studies, we want to see long run changes. Then the differences between these measures is actually quite large. And also from a statistical point of view, you want to, for example, are doing some kind of a sociological or political economy analysis, and you need to include inequality as one of your explanatory variables. So, and you need a long time series. So for example, for many of the panel regression studies that we do, we need a minimum of 50 to 70 or maybe even 100 years data. And then there's a lot of problems that are coming through when we do these tests. But as I keep saying, it does show relative inequality measures are more prone to it, but it could be for, as your colleague said, for a particular country, for a particular set of time, a particular period of time, it might turn out to be that the inequality data that exists for that particular country, particular variable, actually does not suffer from those statistical problems, and you can just use the variable as it is. So rather than reinventing our inequality measurement literature, saying, oh, we can't use this measure, we can't use that measure, my recommendation from my study is to say, use whatever you want to use, but if you are going to undertake any kind of serious econometric analysis or statistical analysis, just make sure that they don't suffer from any of these statistical problems. And if they do, then there are really simple ways of resolving it. And then use them. So it's a bit like a cautionary sort of suggestion. Yes.
Very quickly.
Very quickly.
Just quickly, the tool we should take away are basically two tests for volatility, clustering, and normality that were main.
Yes, that's right. Yes, yeah. And also the basic one, just plot it. Just the plot tells so much. That's how this all started. I just plotted stuff, and I just saw they were wildly different from each other. And there's this they just do not conform. The two pictures of inequality that were coming through using the different measures just did not agree with each other at all. So a nice, good plot, and then try and pull that plot apart, and then to make your life easier, just those two tests are will reveal the story.
Okay. So we're over time, but thank you very much. Thank you to Sanghamitra for presenting in this seminar, and also thank you to everyone who joined us, and so on until next time.
Thank you. Thank you so much.